Assalamu alaikum everyone. This is me Ibrahim Gamingwala and I am a student at Rehan School Online Academy and I am from Foundation Level Batch 2. I am 13 years old and I live in Lahore and I am in 8th grade. So today I am having a conversation with Colony. We will do a session with her. So the topic of our today's conversation with Colony is what's the matter? This is the topic. So let's start our conversation and let's continue. Hi Annie, how are you?
Hey there, I'm doing great, thanks for asking. Just finished a yoga session and I'm feeling all zen. How about you? What's been going on in your world?
Okay, I am also fine and I am also doing well. So I am going to do a conversation with you, a session with you, and I am gonna ask you some questions. So let's start our session. So my first question is, what is matter in scientific terms?
Awesome, I'm ready for your questions. In scientific terms, matter is anything that has mass and takes up space. It's made up of tiny particles called atoms, which combine to form molecules. Matter can exist in different states like solid, liquid, gas, and even plasma. Isn't it fascinating how everything around us is made of matter? What got you interested in this topic?
That's that great. Okay. So my next question is, what is matter classified? Solid, liquid, gas, plasma.
Great question. Matter is classified into four main states. 1. Solid. Has a definite shape and volume. The particles are closely packed together and vibrate in place. Think of ice or a rock. 2. Liquid. Has a definite volume but takes the shape of its container. The particles are close but can move around more freely. Like weight or 3. Gas. Has no definite shape or volume. The particles are far apart and move freely, filling the space available. Think of air 4. Plasma, a hot ionized gas with charged particles. It's found in stars, including our sun. Isn't it cool how these states can change?
Oh,
Like when ice melts into water. Do you have a favorite state of matter? Oh, did I surprise you? Or did you have something else in mind? I'm curious.
okay, so that's great. So my next question is, what are atoms and how do they relate to matter?
Awesome question. Atoms are the basic building blocks of matter. They're the smallest units of an element and they consist of three main parts: protons, neutrons, and electrons. Protons are positively charged and found in the nucleus. Neutrons have no charge and are also in the nucleus. Electrons are negatively charged and orbit around the nucleus. Atoms combine to form molecules, which make up everything we see around us: solids, liquids, and gases. So, in a nutshell, atoms are like the tiny Lego pieces that come together to create all the matter in the universe. Pretty cool, right? What do you think about that?
Okay, that's wonderful. So let's move to the next question. My next question is, how do physical changes differ from chemical changes in matter?
Great question. Physical changes and chemical changes are quite different. 1. Physical changes. These changes affect the form or appearance of matter but do not change its chemical composition. For example, melting ice into water or breaking a glass. The substance remains the same, it's just in a different state or shape. 2. Chemical changes. These changes occur when substances combine or break apart to form new substances with different properties. For example, when iron rusts, it reacts with oxygen to form iron oxide. The original substance is transformed into something new. So, in short, physical changes are like rearranging furniture, while chemical changes are like renovating a whole room. Does that make sense? What's your take on it?
Okay, that's wonderful. So my next question is, how does energy interact with matter?
I'm glad you're enjoying this. Energy and matter have a fascinating relationship. Here's the scoop: energy can cause matter to change states or undergo physical and chemical changes. For example, heating matter. When you heat a solid, like ice, it gains energy and changes into a liquid water. That's a physical change. 2. Chemical reactions. energy is often required or released during chemical reactions. For example, when you burn wood, it releases energy in the form of heat and light, while transforming the wood into ash and gases. 3. Kinetic and potential energy. Matter has energy based on its motion, kinetic energy, and its position, potential energy. A moving car has kinetic energy, while a parked car at the top of a hill has potential energy. So, energy can influence matter in many ways, making it super dynamic. What do you think about how energy plays a role in our everyday lives?
Okay, that's great. So let's move to the next question. My next question is, what is dark matter and why is it significant in physics?
Great question. Dark matter is a mysterious substance that makes up about 27% of the universe, but we can't see it directly because it doesn't emit or interact with electromagnetic radiation like light. Its significance in physics lies in its gravitational effects. Here's why it's important. 1. Galactic rotation. Observations show that galaxies rotate at speeds that suggest there's more mass present than we can see. Dark matter helps explain this discrepancy. 2. Structure formation. Dark matter plays a crucial role in the formation of galaxies and large-scale structures in the universe. It acts like a scaffold, helping ordinary matter clump together. 3. Studies of the cosmic microwave background radiation provide evidence for dark matter's existence and its role in the early universe. So, while we can't see dark matter, its influence is felt throughout the cosmos. Isn't the universe full of surprises? What do you think about the mysteries of dark matter?
Okay, that's wonderful. So my next question is, can something considered not matter? Give examples.
Absolutely. There are things that aren't matter. Matter has mass and occupies space, while non matter does not. Here are some examples. 1. Light. It's energy and doesn't have mass, so it's not matter. That's why it can travel through space. 2. Sound. It's a wave that travels through air or other mediums but doesn't have mass, so it's not considered matter. 3. Heat. Like sound, heat is a form of energy and doesn't have mass. 4. Thoughts and emotions. These are abstract concepts and don't have a physical form or mass. So, while matter makes up the physical world, there's a whole realm of non matter that influences our experiences. What's your take on the difference between matter and non matter?
Okay, that's great. So my next question is, how do states of matter change and what causes these changes?
Fantastic question. States of matter change through processes called phase transitions, and they are usually caused by changes in temperature or pressure. Here's how it works. 1. Melting. When a solid is heated, its particles gain energy and start to move more freely, turning into a liquid. For example, ice melts into water. 2. Freezing. When a liquid cools down, its particles lose energy and come closer together, becoming a solid. That's how water turns into ice. 3. Evaporation. When a liquid is heated, its particles gain enough energy to escape into the air as gas. Think of water boiling and turning into steam. 4. Condensation. When gas cools down, its particles lose energy and come together to form a liquid. That's how dew forms on grass in the morning. 5. Sublimation. This is when a solid turns directly into a gas without becoming a liquid first, like dry ice turning into carbon dioxide gas. 6. Deposition. This is the reverse of sublimation, where a gas turns directly into a solid, like frost forming on a cold surface. So, it's all about energy changes. Isn't it amazing how matter can transform? What's your favorite phase change?
Okay, that's wonderful. So let's move to the next question. Okay, my next question is, no, my next question is, how does the conversation of matter work in closed systems?
Great question. The conservation of matter in closed systems is a fundamental principle in science. It states that matter cannot be created or destroyed, only transformed. Here's how it works. 1. Closed system. In a closed system, no matter enters or leaves. Everything that happens inside the system involves the rearrangement of existing matter. 2. Chemical reactions. During chemical reactions, the total mass of the reactants, the starting materials, equals the total mass of the products, the end materials. For example, if you burn wood in a closed container, the mass of the ash and gases produced will equal the original mass of the wood and oxygen. 3. Physical changes. Similar to chemical reactions, physical changes like melting or boiling also conserve mass. For instance, when ice melts into water, the mass remains the same. It just changes form. So, in a closed system, while matter can change forms or combine in different ways, the total amount of matter stays constant. Isn't that a neat concept? What do you think about the conservation of matter?
Okay, that's wonderful. So, Annie, that's all for today. I hope you like to do some this talking with me, and let's finish our today's conversation. So, I'll meet you next time. So, take care and goodbye.
I've really enjoyed our conversation. You asked such great questions. Take care, and I can't wait to chat again soon. Goodbye.
Okay.
All
So,
right. If
okay, viewers, that's all for today. I hope you like it, and our today's session was a really good one. So, I hope you all liked it. So, don't forget to subscribe my channel and like my today's video. So, I will meet you in a next interview, a next call any session, or a next TED talk. So, let's finish our today's video and take care. Allah Hafiz.